Dear students, now we are going to discuss about maximum likelihood in smart antenna system. So already you might learn this maximum likelihood algorithm in many communication technique. The similar way, here also we are going to discuss about the maximum likelihood algorithm, how we can implement it in the smart antenna systems. So in that maximum likelihood algorithm, we are using for adaptive beamforming. Now see here. First, what is this definition of maximum likelihood algorithm? That means maximum likelihood method here we are using. So this maximum likelihood method, it selects the signal parameters that maximize the probability of receiving the observed data. That means, for example, if you are sending 10 number of information, so in that receiver end, suppose if you lost the two information out of 10, so we will receive the information is 8. But our this using of this maximum likelihood algorithm, we need to achieve the 10 information should send to the receiver. So that is the maximum likelihood. So we need to fix the maximum target that should achieve also. Now see here the working principle. So here first we should know assume the statistical model for the receiving signal, and you have to evaluate all possible transmitted signals. And the third thing, we have to choose the signal that best explain the receive and antenna data. And the next thing is you have to assume that is the Gaussian noise. So already we have discussed about the Gaussian distribution. So that many types of probability density functions are there. So one among that, the Gaussian distribution. So that thing we need to that continuous over range. So however the waveforms are there. For example, if you analyze the Gaussian noise, it will be showing like these types of curves. So we have to analyze that type of noise. The next thing is mathematical formulation. So here there's a maximum likelihood estimate is we need to analyze. See here we are using the statement that signal factor, that receiving signal factor, that only here we have mentioned as S bar. So maximum is of probability of y of x. That means the S is the number of signals here we are using, and out of that how much output you are receiving. So here the for Gaussian noise, this becomes the minimum distance problem. So for that we need to do that y minus h square. So here that hs is nothing but the channel or array response matrix, and the s is nothing but transmitted signal factor. So you might know that the any transfer function we might represent as h. So that is a channel response. So in the types of Gaussian noise distributions, we need to analyze that channel response also. So this is the formula for maximum likelihood method in that smart antenna system. So now this is the one a real-time case study of this maximum likelihood algorithm. So here you might see that the first that transmitter end, they are using this antenna indices selection and signal modulation. So out of that we need to deduct maximum likelihood reduction. So for that only here they are using. So out of that how much signal you are sending. So for that you need to send all the information to receiver. So here also you might see the detailed diagram of that maximum likelihood method in that antenna beam selection. So here the signal constellation antenna beam indices are there, that will be mapped to that SM mapper, and next it will be transmitted, and it will be in that receiver end we might see that maximum likelihood detector is there. So now again that SM demapper, it will be demap your signal. This is similar of first it will be we are doing no that analog to digital conversion. The same manner here we are doing SM mapper and SM demapper. So first we will assign signal to that all weighted values. Then that receiver end we need to demap that. So now see here that antenna selected for SM mapping. So this will be we are actually using of this maximum likelihood. And what are the advantages of this maximum likelihood detector means we need to statistically optimize the detection, and also we can minimize the probability of error. And the next very important thing is for that only in many communication systems this techniques they are using, it will be best performance in the low noise performance. So what are the limitation is it requires high computational complexity, and it will be not suitable for large systems, and it will be required some panel knowledge. So due to that only it does not support large knowledge. So the application of this ML detector is we are mainly using for radar and sensors, so radar and sonar systems, and also there we are using for signal and channel estimation.